What is up, everybody? My name is Zerkron45. Today I'm doing a tutorial on how to create this Plexus particle in Blender only. This is going to involve a few add-ons that I will be posting the link to in the description, because most of them are pre-installed. So let's get straight into things here. First things first, load up Blender. Rather important step. Alright, so delete the default cube, delete the lamp, and go to the first angle on the number pad, and Control-Alt 0 to... I don't actually need to, I forget I have number. My screencast key. Alright, so we have the camera set up. Now, let's make a new plane. Shift-A, mesh plane. Let's just scale this up, just for the sake of it. Actually, that's not perfectly liquid. Alright, so now if we go to W and then subdivide, we can see that, it subdivides. But that's not what you're looking for. What we should be doing is increasing the fractal here, which will make it so that it has more displacement to it. Let's increase this, and maybe change it more along the normal, just to give it a few more bumps. And then let's subdivide again, and increase our fractal amount again, just so that we can have a few more bumps in it. Actually, let's increase the amount of subdivisions, and maybe decrease the amount of fractal. So that's good. Now let's tap out, and we can see that they have square faces. Good, for a Plexus look at least. So we'll be adding a triangulate modifier, which just automatically turns everything into a triangle, which usually looks really good. So, now that we have this, we go to our node editor, and create a new material. We'll be deleting our diffuse material and inserting a shader, add shader, or emission shader. And then we'll be adding the add shader later. In the meanwhile, we'll be adding a UV map. So let's switch to our UV image editor, tab into edit mode, actually, Control E. I don't even need to be mark seam. And as you can see here, all of them are red. This is an important step. Basically, the mark seam, when we unwrap it, it will separate all of the faces and vertices. So once we unwrap it, you'll see that everything is now separated. Now that we have this, actually I'm going to be explaining why we're doing this. The reason we're doing this is because we're going to be using a noise texture to create the patterns in the Plexus material. And if we just used a regular noise texture with this unwrapping, we would be seeing clouds and lines going across these planes, and we do not want that. So what we're going to be doing here is changing our origin point to individual origins rather than the default, which is bounding box, essentially. Now we have individual access to all of these little faces, which means we can scale them all to 0, which thus causes us, if we add a noise texture over here and tell it to map to our UV and plug the factor into the color, we'll see that they're all individually colored. And now if we go to converter and color ramp and then change it to constant, you can see that we now have the start of our Plexus. This, however, does not look very good, so we'll be changing the scale to make it so that we have better, the scale is basically the seed of the Plexus. Actually, you could animate that and make something really cool. I didn't realize that. Alright, so now, if we go to here and input a wireframe value, you can see we have the other half of our Plexus. Now, the default value is pretty good for the wireframe, so we'll just leave it at that. So if we add a converter and then another color ramp, actually we could just duplicate this one and plug this into here and multiply it with our wireframe. I'll explain why we're doing this in a moment. So the reason we are multiplying it with our wireframe is if we look over here and see this half of the Plexus, you can see that this half is going to be a bit bigger than the actual faces, so we'll be moving the white down a bit to increase the amount of connections. Basically, this is our connection slider. The more black, the less connections, the more white, the more connections. And this is why we have to unwrap it, because if we just use generated coordinates, we'll show what that looks like here, it will not look like Plexus at all. As you can see, that does not look like Plexus. So we'll be switching it back to our UV map. And we can go over here and see that if we add these two together, we will see a very Plexus-y looking thing, our material. So In the meanwhile, we are not going to be doing this just yet, so we'll delete that. And if we go over here, we can see that we have two shaders, or we're going to have two shaders. The shader for the faces, and then the shader for the wireframe and the vertices. The vertices I've not done yet. So, for the vertices, we will be doing Shift-A, Input, Geometry node. This has something called parametric, which, if you notice, when you look closely, you can see it marks the vertices. Let's show that with a converter to separate x, y, z. We'll separate the x and the y. The z is, useless. Alright, but the y value and the x and the y value are going to be very useful. So we'll add another color ramp. Let's just duplicate this one since it's already constant. And then shrink this to where it's just like a little point. But we don't want to make it too small because we want it to be distinguishable from our wireframe. So once we do that, we can add it with another separate x, y, z, and separate the y value instead of the x value. So we'll be adding them together later, so let's put this over here. And connect these two with the add node, and you can see that we are now marking all of our vertices. As a matter of fact, actually, let's make these a little bit darker. Just drag this up. You don't have to be perfect. Nothing is perfect. Alright, so we can now add these two together with the add node. Make sure you're using Mix RGB because it's a bit easier to handle. And let's switch these two. And then increase this with a multiply node and set this value over here to 4. And I did not do the, I said multiply. Alright, so now we have our vertices being marked and our edges being marked. Now, if we connect these two together, it will not look good. So we will be adding this shader to here. And then using an add shader, there's a simple strategy I discovered. If we just solo this, and then shader, add shader, and then just connect it with a transparency shader, you can see that we now have isolated the wireframe. Now, if you just add it to the emission, it will end up looking pretty darn good. We can decrease the strength over here to make sure our faces aren't too bright. And I believe that's looking pretty darn good. And I forgot to actually multiply these values with the wireframe over here with our noise texture so that we don't have a bunch of floating vertices, because if we hide this, you can see that we now have floating vertices. If we look over here, you can see a couple here and here, and that does not look good. So we will be getting rid of those using our noise texture once again. So now that we have these, it looks pretty darn good. So let's darken our background here, just so we can have a better view of what we're doing next. What we're going to be doing next is adding a sort of taper, and if you look at the image here, you can see that I have tapered it, which just makes it look a little bit more organic in my opinion. So we're going to be doing that with our parametric value. Very useful value, evidently. So we're going to be separating the XYZ, and then converter, math, it's because, it's just a little bit easier to manage here. We'll be using a multiply, actually add, and then invert the Y. So now that we have this value, we can put it over here and add our useful color ramp and change it to linear instead, so that we can create a sort of taper. And now you can see that if we need to subtract this a bit, or multiply it down, we can see that the edges like here will now be slightly tapered. Actually, did I invert the incorrect side? Well, what happens if we just invert both? Yeah, let's just invert both. Alright, so we can now see that if we don't multiply this too much to where it's like multiplied out of existence, we go to here, nope, wrong value. Go to here, wow, we're using a ton of colors. Alright, and then multiply, you can see that we now have a little taper on these vertices, which just looks a little bit more organic. It's just a subtle thing that just makes it look so much better. Now, this obviously looks actually a lot like Plexus, but it doesn't have, something looks missing, right? Well, that's because we need to add depth of field. So we go to our camera's aperture settings, let's just focus on our friendly plane over here, and turn up the size, we now have a good looking depth of field effect. If we rotate our Plexus, not the camera, the Plexus, we can see that this actually looks very, very, very good. Now, if you want to colorize it, you can either do that in the compositor or in the node editor. I'm going to be showing how to do it in the node editor. With the node editor, you can just go to the color ramp here and change this to blue, and then go over here, use a multiply node, and just use the eyedropper tool to get the same color. And now you have your lovely looking Plexus. If you want to decrease the amount of like visibility to the vertices, you can decrease this as like 2, you know, just to make it look a little bit less obvious. Now, if you want a pretty much noise-free render, I suggest installing something called denoise. It is a noise, it's a denoiser that's completely free, developed by Remington Graphics, or at least I think it was. And if you render this, it's gonna lag a bit because I am screen recording and using GPU. And I'm using 123 samples. All the above will cause for a laggy render. And do I have After Effects open? I probably do. But if I finish this render, which I will get to you when it is done. Alright, we have successfully rendered it. It took around 25 seconds to render, not including the denoising factor, and if we look at it, it looks, you know, noisy. And I reduced the samples to 10 because I wanted this to render extremely quickly. So now if we do a quick denoise here, you'll see that our render becomes pretty much noiseless. It'll take a couple of seconds, and 3, 2, 1, yep, there. And you can see that it is noiseless. It is a really good denoiser. I highly recommend it for all you Blenderians out there. And that is all for this tutorial. Thank you very much for watching. If you enjoyed this tutorial, leave a like. If you really enjoyed this tutorial, please subscribe. And if you found it useful or need any advice, leave it in the comments below. I'm not afraid to answer any questions, and I would be glad to answer yours if it's urgent. Now, adios, mi amigos. Please subscribe, like, and comment.